I'd like to introduce our next speaker. It's Dennis Todey. Dennis is the director of the Midwest Climate Hub, which is located in Ames. I did a quick web search. I did not know Dennis before. It's very obvious. He's very well known, an accomplished national speaker on Midwest climate issues. And today, Dennis will provide us with the weather outlook for this coming season. So welcome, Dennis.
Never applaud before you hear the speaker talk. Don't do it. Bad thing to do. Okay. How's everybody doing? I told Bruce I went from whether I like the position in being the last thing keeping you from food or talking to you right after you eat food. So now I got to be engaging now to try to keep you awake. And trust me, I understand this situation. When I was working on my PhD, I was the teaching assistant for a meteorology class, introductory meteorology class at Iowa State. And this is back pre-PowerPoint days. So the professor had everything on slide trays. So as the teaching assistant, I did a weather briefing at the start, and then I went to the back to make sure the slide trays were working. It was 2 o'clock in the afternoon. Everything was on slides, and you didn't have to take any notes because he sold you a book with all the notes in it. And it was the biggest lecture hall on campus, and it tended to be warm in there. So I'd be dozing off sitting back in the back anyway. So anyway, thanks for having me here. It's good to get back to Minnesota. I used to come over here frequently when I was at South Dakota. I was the state climatologist there for 13 years. We had a little SDSU reunion over here of former SDSU folks. So that was good to see everybody that way too. But yes, I do work for USDA now, and we work in I'll talk a little bit briefly more about the hub here as we go along. And I wish I had seen Bruce's presentation before I put this together, because there are some things some additional pieces, additional slides that would have been really helpful to go along with that. So I'll talk about some of those as we go along. And I have 3 hours, right, Bruce? Okay, so 40 minutes. Ready? Here we go. Okay. And yeah, usually as an old extension person, I like to let people ask questions up front, but since we're online too, we'll have to pose that. But any weather or climate questions you have, shoot those out along the way. Okay, briefly about the climate hubs. For those of you that may not have heard of us, and to give you a little perspective, because there are several regional climate entities that you may hear of. Everyone has a little bit different purpose. So we sit in USDA. We cover an 8-state region that is Minnesota to Missouri over to Michigan and Ohio. That's our official 8-state region. So that covers most of the Corn Belt. Doesn't get the western parts. We do extend out and work with our partners out in the high plains to cover row crops in those areas, because their emphasis out in the plains area is more livestock rangeland issues. So we do that, and then we're working on a trade with Kentucky for the Southeast for a player to be named later. Anyway, that's that's the area we're working on. We try to work across the corn, soybean areas through all this, lots of row crops. So nitrogen is a big player. But we also do work with a wide range of crops. You know, those don't always get as much attention, but there are some very high value crops that exist in this area. How many of you like your pumpkins, your pumpkin pie at Thanksgiving? How many of you like those? You know where that comes from? Anybody know? Anybody online? Illinois. More than likely, about 80–90% of the canned pumpkin in the country comes from central Illinois, around the Peoria, Morton, Illinois area. So that's a whole different set of issues than we do with row crop. And then you get into tree fruits and those kinds of things. It's all kind of interesting issues. So anyway, our job, without going into great detail, from this overall standpoint, is understand the changing climate, communicate that to agriculture, and help agriculture deal with that with current conditions and going ahead. So that's a large part about what we do. That's the short version. There's a lot more to it that goes along with that. My background is as a meteorologist, ag climatologist, whatever hat I need to wear that day, I use them. So talking about current season issues, droughts, those kinds of things we all go talk about. Okay, briefly, this one wasn't going to apply, but during our conversation and a little bit of Brad's, it made me going to leave this in here. this is something, and the other thing is if you want, for people online, you can grab the websites all along the way. Anything I show you today is all publicly based websites. So you can get access to all this information. Okay, one of the things we deal with lots of issues with changing climate. One of those is looking at spring and fall freeze dates, those kinds of things. Brad brought up the issues with soil temperature. That's another project that's in process about trying to develop soil temperature climatologies. We're working with our partners with the Midwest Regional Climate Center at Purdue. But this is one that has come to fruition, that it exists. And this is looking at spring and fall freeze dates, how spring and fall freeze dates are changing. And this website allows you to go in and look in at a county level how spring and fall freeze dates have been, what the climatologies are of those since 1950, and see how they are changing. And it's not only 28 or 32, you can look at everything from 20 degrees up to 40 degrees. So this website will get you there. And what I threw these two in just for interest's sake, so you can kind of see what's happening. The top graphic on here is the first fall 20 and 28, using 28 as our freeze dates here. And the bottom is the spring 28. Last time we hit 28 in the springtime. And going on the website, you'll be able to see it better. But basically, the darker the color, the bigger the change towards earlier or later. So the first fall freeze over much of Minnesota is getting later. The first fall freeze in the spring is getting earlier overall, since 1950. The areas that are lighter colored in the blue color, if you're not colorblind, the trend is flat or actually slightly differently. So there are some interesting regional differences that are part of this. So this is something you can look at and say, hey, how are things changing spring and fall? Now, this doesn't help you with that spring wetness issue. That's a whole other set of problems. But this does give you an idea about spring and fall freeze dates you can look at and look at over time. Now, also, Brad brought up growing degree days. I wish I'd had time to be able to get a slide in. We, as another project, you can get access to at the Midwest Regional Climate Center website. Also at the Midwest Regional Climate Center website is a growing degree day tracker. It allows you to track growing degree days at your location from your planting date anywhere across the Corn Belt. It allows you to pick your location. It allows you to pick your variety, how long a variety you're using. It shows you how many degree days you've accumulated since planting. And it also shows you how that compares to average and a projection throughout the rest of the growing season. So if you just look at Midwest Growing Degree Day Tracker or Midwest Regional Climate Center Growing Degree Days, you should be able to find that. And if not, send me an email and I'll point it to you. It's really very useful. Talking with Yeba ahead of time, he said they still use it. And I'm glad that it's still getting used. It's been around for 10 years and still getting a lot of use. Okay, let's go on. And since I was tasked with what's going on this year, we're going to dive into that part of it here, where we are right now. Now, the first thing we always do when we're doing an outlook, it's setting the stage. Where are we right now? Where have we been recently? Because we need to know that to give us context going ahead. So look at precipitation last 30 days. And this is actually a couple days old. That's actually older than I thought it was. I thought I had updated those, but anyway, it's a general idea. It gives you a general concept. Precipitation, total precipitation, upper left-hand side, percent of normal precipitation, lower right-hand side. So anything that's in the redder or brown or something is, the drier, the greener or bluer it is, the wetter it is. So precipitation has actually been heavier overall in the southeast Corn Belt. You'll see over Minnesota, the southern half of Minnesota, the 30 days ending the 22nd of January, quite a bit above average. But remember, this is winter precipitation, okay? Winter precipitation the winter precipitation climatology is fairly low, so above average in winter is not that much more precipitation. If we go back and look at the same time period since October 1st, what you end up with here is the situation of, precipitation left-hand side, percent of normal lower right-hand side, and that above average kind of goes away. And we're still relatively dry across southern Minnesota and northern Minnesota particularly, and then the eastern Corn Belt was much drier there too. And I'm concerned, I'm hoping this is not an older version. I'm hoping we have the updated version. I hope we didn't get the wrong slides here. So let's find out where we are. Okay. So that's precipitation. Let's look at soil moisture. When we're talking precipitation in the way of crops, really what we're trying to get at is what's going on in the soils. And obviously that isn't always, they're related, but the context sometimes can be somewhat different. And we don't have good soil moisture monitoring on a widespread basis across the Corn Belt. There are continuing efforts to improve it, and we're gradually improving it, but it's still a tough thing to try to assess. There's lots of different ways of measuring it. There's lots of different ways of trying to display it. So these are two that I show because they give us a larger picture on where we are in the way of soil moisture. I probably should have zoomed up over Minnesota, but it gives you an idea where we are. So this is modeled soil moisture, a couple of different models. One is pretty much completely modeled soil moisture based on rainfall, evaporation, that sort of thing. And that's the one in the lower right. The one in the upper left is a satellite-based one, and it's percentiles. Basically, what you're looking at is percentiles. So the drier something is, it's lower on a ranking scale. The bluer or greener something is, it's higher on the scale. Basically showing you that across most of Minnesota, in fact, most of the Western Corn Belt, still some quite dry soils. Individual locations vary a little bit, but still quite dry soils. Let me pose that question to you folks who are in the area. And let me do by a show of hands, and people online, maybe you can raise your hands or chime in if you want to. One of three things: are soils around you wet? Are they around normal? Are they dry in your area? How many around you say soils are wet? Okay, for those online, nobody's saying they're wet. How many saying they're near normal or somewhere close? Maybe a third of the room or a quarter of the room. Okay, how many say your soils are dry? Okay, by far of everybody. Okay, that's always a good, I always like to do that ground check that are the models showing up with what people are saying. So, okay. All right, just from a completeness standpoint, here's another NOAA product that has how much snow is on the ground. This is snow depth. There are a number of different pieces that go into this: on-ground measurements, airplane measurements, satellite, that sort of thing. Scale, the kind of tealish color is 4 to 8 inches, and then the scale goes up after that. So still a decent amount of snow cover across most of the upper Midwest and Northern Plains. If I did a comparison to average, the Northern Plains would actually be above average snowpack. I think eastern Minnesota to the east would be actually below average in the way of snowpack comparatively. And then you get down to our area and south, and there's no snow down in that area. Now, again, while this does provide moisture, very little of that's going to get in our soils. And I have to keep reminding people about that, well, we've got moisture. Well, yeah, we got snow, but it's going to lead to runoff, which is good in its own right. But we really need to get rid of this and get our soils thawed before we can start getting any moisture in the ground to speak of. Speaking of which, here's a graphic that is from the National Weather Service. They work with a number of cooperators where they actually do a different kind of sensors. These are not sensors in the ground that measure soil temperature, but they actually are kind of a tube that assesses the frost depth. And it shows kind of where the frost depth is. Most locations, in southern Minnesota are running up to a foot. Must be down at Lamberton showing no frost depth at this point, which kind of surprises me a little bit. You go a little further north, you kind of get up in the 1.5 area. You get over into South Dakota, like the Aberdeen area, they're close to 3 foot for frost depth, which didn't surprise me too much given the dryness of soils. If we got very cold back in December, and then we actually warmed up, and that kept us the frost depths from going very deep. I had real concerns that we were going to get very deep frost depths and have some issues with that. We have had some issues with that already this year. Okay, compiling a bunch of these pieces together, here's where we are with the U.S. Drought Monitor. How many of you are familiar with the U.S. Drought Monitor? Raise the hands. Okay, for those online, about half the people here. This is for those of you not, and just a reminder for other folks, this is a weekly product, comes out on Thursday morning. It is valid as of the data for Tuesday morning, meaning that about 7 a.m. Tuesday, that's a data cutoff time. Anything that happens after that isn't considered in that week's map. So like right now, see, today's Tuesday, right? Information is going on right now, being exchanged as to what the drought monitor map is going to look like this week. This map is created by a single individual each week, but they do get a lot of input from different states across the country. And it categorizes what's going on as anything that's in white, like here in the eastern US, lots of white, no drought issues. The yellowish color is D0, which is considered abnormally dry, not officially drought, but considered abnormally dry. And then your scale goes from a tan, which is a D1 moderate drought, up to D4 exceptional drought. So most of the eastern US, no major drought issues, even in the eastern part of the Corn Belt. Western Iowa, southern Minnesota, and then down through the plains, lots of still ongoing drought issues. Very dry the last couple of years, really haven't had a whole lot in the way of winter precipitation helping them out. We didn't expect that either. But recent precipitation in the eastern Corn Belt has improved their situation. Fall precip, in Minnesota helped a little bit, but we still have a lot of distance to go. From an Iowa context, not as many folks here, but it's a good one to help understand the visual of what we're dealing with. Northwest Iowa in a 5-foot profile. The couple extension folks in Northwest Iowa still go out and they take 5-foot soil cores at the same places in the spring and fall, and then they dry them to get how much moisture is in the soil. In Northwest Iowa, field capacity of a 5-foot soil probe is going to be, maybe 10, 11, 12 inches, depending on what your organic matter situation is like. In the fall, I think their average is around 6 inches of water in that 5-foot profile, plus or minus an inch. The wettest ones they had this fall were 2.5 inches. And there were 2 locations that had a 1/2 inch of water in that 5-foot profile. So that gives you a perspective on how dry the soils are there. They've probably put a little bit of water back on the surface, but we've not put anything back in that profile. So we have some extremely dry soils. So on the good side, I've been telling them field work, you're going to be able to get in the field pretty early this year. I try to give people a little bit of good news, but we've got a lot of water. We got to get back in the soils there. Okay. Jumping ahead, just a couple other things the U.S. Drought Monitor shows. They have change maps, so you can see how the drought monitor has changed at various time periods. So that's always kind of a good thing to get a look at. And then you can also look at, like, even down to a county level, a state level, regional level, at drought coverage over time. And I kept these slides in because there's a question about drought in the Corn Belt that keeps coming up that I won't go into. But I remind people that drought in the Corn Belt is almost an annual thing. We have drought in the Corn Belt almost every year. Now, severity and coverage area, that does vary, but there's drought in the Corn Belt almost every year. If you look at the top graphic here, this is the north central states, which are basically the Corn Belt states. That includes some area outside the Corn Belt, like the Western Dakotas. And you can see that we have coverage on the drought monitor, a couple back in the early 2000s, some less around 2010, and then 2019, some lesser years. Otherwise, we have drought in the Corn Belt every year. So it's not a matter of is there drought, isn't, it's how much and how severe it is. Okay. All right. Now, this fits into, Brad brought up, talking about some of the trends in the way of precipitation. I'm going to hit those again, but I'm going to take a little different spin onto what he showed. So he showed some of the graphics there that we are getting wetter. The graphic I'm showing you here is a national map from the last National Climate Assessment. National Climate Assessment is a congressionally mandated product that assesses what's going on in the way of climate, how it's impacting the U.S. The 5th National Climate Assessment is in process. It will be coming out later this year. Just finished up a public comment period. Lots of stuff goes into this. And there are different chapters. There's a Midwest chapter. Just as an FYI, we're developing a Minnesota version of this for agriculture. There's going to be a shorter document that is going to talk about what is changing in Minnesota climate, how it's impacting agriculture, how we're going to expect it to change in the near future. We will share that when we get that available. We're working around state by state in our region to help develop this. Anyway, the point we're getting at here is the whole upper Midwest, since the beginning of the 20th century, has gotten wetter. Brad talked about that, and that is really the case. And it has brought good and bad along with it. You know, it's expanded some of our cropping options. It has, made drainage an issue, people trying to deal with this kind of thing. It's increased some disease problems. One of my favorite stories actually comes from South Dakota, that, the Dakotas have gotten wetter. That's led to some more corn and soybeans being grown out there. One winter, I did a talk in Western North Dakota, in Dickinson, North Dakota, and I drove across Highway 12 across northern South Dakota, west of the Missouri River. Big corn country, right? West of the Missouri River near the Dakota's border. There was corn that was unharvested. And I said, why was that corn not harvested? Said it was too wet. They couldn't get it out of the ground. Okay. So water is probably our biggest climate change here. There are other issues, lots of other issues we can talk about. Water's probably been our biggest one. Now, Brad did talk about the seasonality of it, the overall changes. Seasonality is our big player here. Across the bottom, you can see several different ones, the winter, spring, summer, and fall. So the greener areas are wetter, the browner areas are getting drier. I always like to point out, we've heard about the issues on the Colorado River in the southwestern US, and they're getting drier. And you think about, the excess water issues and drought issues we have up here. Think about, how many of you have been to Arizona? What's the climate in Arizona like? It's dry, it's desert. Okay, it's desert, you put a lot of people there, and then you try to grow ag things and then make it drier. Start doing the math, and it doesn't work. It doesn't work. So if anybody in ag is looking for something different, I know corn growers is probably going to shoot me down for saying this. If you can think of something else to grow that they can grow in California, you can grow it here. Try growing it here, because they're not going to be able to grow the things that they're doing out there. Anyway, side story. Let's look at this for Minnesota. Now, these are kind of hard to see, but I can show you where these are. And again, I'll share these slides with you. But these are time series, since the late 1800s. So the x-axis on all these is 1895 until the present. Each one of those points is the season for that year. So the upper left is winter, the upper right is spring, the middle left is summer, and then the lower right is fall. Well, how things are changing. And the two line, there's a blue line that shows a trend for both of these. And the spring and fall has the biggest trend, and they're probably the most significant. Winter doesn't have a big trend, but if you look over up here in the way of winter, you've seen the last 15 years, we've actually gotten more precipitation during the winter, which is a climate change that's been projected. More of our precipitation occurring during the cold season starting to occur. And then if you go into the left here, summer precipitation is actually flat. Okay, I've got more to talk about on the summer perspective here. And this is something that I took note of about a year ago, and have been talking about a lot of it since then, because I think it's a good point to talk about. While we are getting more precipitation, it is getting more seasonal, much more seasonal. This is a graphic from Redwood Falls. Now, when we talk about climate change issues, we talk about longer term issues. But when we compare to averages, we use the last 30-year averages. So what I'm showing you here is data for Redwood Falls, and it's the 30-year average from 1991 until 2020. And so the lines are the average monthly temperatures, high temperature, average low temperature, and then the mean temperature, and it's January through December. So the warm period in the summer, cold period in the winter. The green bars are average monthly precipitation. Now, one of the reasons why Midwestern agriculture is so productive is, one, we have soils, but two, unlike certain climates, the hottest time of the year, when crops use most of their water, we continue to get rainfall. But in parts of our region, southwest Minnesota, northwest Iowa, and a little bit west, south central and southeast Minnesota haven't seen this one yet. We're seeing a drop off in July precipitation. So we get the peak in June, and then we'll see a drop off in July precipitation. Now, how many of you grow corn? Raise your hands. Okay. How many of you want to see less precipitation in July? Online noted there was probably about 2/3 of people raised their hands, but no one said they wanted less July precipitation. And see, that's what we're producing from a crop growing perspective. We're pushing more precip into the early part of the season, and then we're getting less mid-season. So this is a real issue from a management standpoint that we're going to have to think about how we want to deal with it. I don't have the answer right here now, but it's something that I wanted to bring up. Okay, here's Lamar's in Northwest Iowa's even more, an even bigger drop off, which has a number of set of issues with it. Okay, let's go ahead, and we're running on time here, so let's get an assessment on where we're going from this spring and into the summer. Okay, now what I'm going to show you, we're going to talk about El Nino, La Nina status. You've probably heard about El Nino and La Nina. They are not the end all and be all of everything in the way of climate, but they are helpful because they do tell us a few things about what's coming, or lack of being able to tell depending on the situation. We've talked a little about trends already is another thing we can use. Computer models is another thing that goes into these, but they need some interpretation. I also include jokes on the right-hand side of what things don't work well from climate outlooks. And yes, trust me, onions and walnuts, I know people who claim they can forecast using onions and walnuts. So that's another story for another time. First off, end of La Nina. La Nina is the opposite phase of El Nino, or when we have colder than average water in the equatorial Pacific. And that's what I've got. The animation here shows this area of colder than average water along the equator in the Pacific. And that is indicative of La Nina conditions. But you'll see as this animation goes on and the time frame involved, the severity of the blue is getting less and the coverage is getting less. Indications that the La Nina is weakening, and finally after 3 years is probably going to go away. So from our standpoint, that's a good thing. La Ninas during growing seasons particularly have a tendency to lead to increased chances for drought conditions. So that's a positive for us as this is going away. We'll talk about what might be coming up next here in just a second. So let's skip this one. Why do we talk about this? Well, because it does give us some indications, El Nino events, La Nina events, it does give us some indications on what our growing season or what things can happen during different times of the year. For you crop growing folks, you also are looking at South America. It also influences what happens in South America. That's why we point out what's happening with El Nino and La Nina. So where are we headed with this? Well, this is a graphic from a NOAA cooperator at Columbia University that talks about the probability of being in La Nina, El Nino, or neutral conditions. You're in one of those three phases always. And the bars or the x-axis is 3-month periods going from December, January, February. Here's like March, April, May. Here's June, July, August, summer, and then the fall, August, September, October. And the blue bar is the probability of La Nina happening during that 3-month period. The red bar is the probability of El Nino, and the gray bar is the probability of being in between neutral. So we're in La Nina right now, and that is likely going to fade as we go into the spring. Neutral is likely what the situation into the growing season. But then later on, you see that El Nino creeps in pretty quickly as we get into the end of the growing season or into the fall. Now, this would be a fairly quick transition historically, so I'm questioning whether it's going to happen or not, but it's something we're going to keep an eye on as we go along into the growing season. Now, note this is not a bad thing. El Ninos during the growing season tend to make for better growing seasons. This harks back to my PhD a long time ago. We helped to get some of this stuff started, but El Ninos during the summers tend to make for better summers. El Nino seems more likely, especially next winter. El Nino winters tend to be milder winters. So if you like your winter sports, maybe it's not as good a situation for you overall. Okay. One more quick thing here. As we transition to neutral conditions in the spring, let's skip this. Let's skip this. Okay, let's get right to the guts of what we're going on here. Now, quick promotional piece about the Midwest Climate Hub. I'm going to show you some outlooks here from NOAA, from the NOAA's Climate Prediction Center that talk about outlooks going out into the future. They are for a wide range of sectors. They're not specialized for agriculture. We develop an ag outlook where we take these outlooks and put an ag focus on them. In fact, we just updated one yesterday, so I'll show you where to get a link to that here in just a second. Anyway, next week, next 7 days, what is expected in the way of precipitation? Not much up in our area, but you see from the southern, southern Mississippi area to the eastern Corn Belt, a lot more precipitation is possible. Those several inches possible down around the Arkansas area. And you'll also see the eastern Corn Belt has some chances for precipitation too. That is a more likely thing, that the eastern Corn Belt is going to continue getting more active. Northern Plains and Minnesota is still going to be quieter for a while here. Okay, now we're going to walk you through some time periods here. These are outlooks, also from the Climate Prediction Center. Temperature is on the left-hand side, precipitation is on the right-hand side. So the week 2 outlook, Minnesota or part of Minnesota into the east has a better chance of being warmer in week 2, but that active pattern, that green area, eastern Corn Belt, indicating eastern Corn Belt likely more active, even Minnesota a bit more active possible for this time of year. If we jump ahead for the month of February, now you see Minnesota is kind of in the middle in the way of temperatures, better chances of warmer to the southeast and cooler to the west. Minnesota does have a slightly increased chance for being wetter during the month of February, but then that eastern Corn Belt area continues to be more likely wetter. Then February, March, April, that first part of spring, the eastern Corn Belt stays wet. Minnesota kind of stays in the middle of things without too much to say as we make this transition. And then here is March, April. Let's see, this is, March, April, May. So spring, we don't have a whole lot we can say, because as we get between El Nino and La Nina in that neutral category, we don't have a lot of indications one way or the other. So that's why we talk about what our current conditions are, the dry soils, that we will expect usual wetter spring, maybe not excessively wet the way it looks right now. And then the summer, again, not much in the way of precipitation, maybe a slight chance towards warmer. Our trend in warmer during the summer is minimum temperatures. So, what we're looking at right now from a start of our growing season is dry soils. Once we get the snow melted off, dry soils will probably get moving along. We'll probably carry on some of those drought issues until we can get more moisture back in the soils. The Iowa to the east is probably going to be more active as we go into the spring. Dry soils should, again, allow better field access, better chances for precip. We should see some drought improvement. We may not be able to eliminate it completely, but we should see some drought improvement. And then the summer, I think, will be better than last year from an overall perspective. We've had a couple of years of drought. Multi-year droughts are fairly rare in the Midwest, so I think we'll be improving. And then especially as we get into that chances for El Nino, that just improves our probabilities for our growing season overall. Real briefly, if you like this kind of thing, Outlook, we do a webinar every third Thursday of the month. That's when NOAA releases their outlooks. So we do a webinar with a number of our partners. I'm always on there to answer the ag questions. You have to sign up. It's free, but you have to sign up to get a link. The recording and slides are saved for later if you want to review them later. If this doesn't work, let me know. We can get you on the email list for it. Then our website, and I'll bump here. If you Google USDA Midwest Climate Hub, you'll find us, and that's where you'll find those climate outlooks, those ag climate outlooks. They are off our main website. You can snag that if you want to, or you can get the slides later. And then we'll take you to the end here again, our website. If you want to get on our newsletter list, there's a link there to get on our newsletter list, or you can send me an email. We can get you on there. And that is the staff of the Climate Hub right now, with folks increasing along the way. All right, and I still have a few minutes for questions. Yes, we made it. So thanks for sticking with me, and I appreciate you being here. Okay, how much water is currently in our snowpack, and what is the likelihood of soil recharge from the melt? Yeah, we kind of touched on that. In Minnesota, ranging probably 2 to 3 inches, maybe more in the snowpack in areas. But again, we're mostly frozen underneath that, so we'll probably get a little bit of recharge at the surface. That's not going to get down deeper in that profile. The runoff will be helpful for ponds, wetlands, rivers, all those kinds of things, Mississippi River eventually, but it will not help the soil moisture profile. We need to melt the snow off, get this frost out of the ground, and then get rainfall in there. That's going to help our soil moisture recharge. And then with precip seemingly more intensity, is there anything that looks at soil infiltration compared to that intensity? That's a great question, and it would require more widespread in situ monitoring. And what I mean by in situ, actually probes in the ground to be able to see how deep that profile is. But we don't have that on a widespread basis. Now, the other thing that we do encourage people, and we strongly encourage people, is to make sure they're doing whatever they can to take care of their soils, because with that increasing precipitation intensity and more precipitation occurring in that off-season period, that winter time when our soils are frozen or there's more water in the soils to begin with, that's a better chance for getting runoff and losing more of those surface soil. And the more topsoil you lose more organic matter, you lose more water holding capacity. So encouraging people, really almost screaming in some cases, saying, reduce the tillage in your soils, do things to make sure the soils are maintained, because every time you get a big loss, and even this winter, we had wind blown loss. There was a lot of soil that was topsoil that was blown this winter, even down in Iowa, and even that was soil that was not heavily managed. The winds were strong enough; it was blowing some of that around. Okay, the ideal spring melt conditions for recharge are really melt the snow off, thaw the soils, and then get a couple day rainfall events, not high intensity rainfall events, but widespread rainfall events that allows it to get deeper into the soil moisture profile. Certainly not big events, not heavy rainfall events overall. And the changing rotation at the core of the earth have an effect on climate. That seems unlikely. I'd like to see more work done on that, if there is any work done on that, but that seems to have an unlikely effect on the way of climate. And should farmers be concerned with washing out of their field? I'm not sure what they're asking in this. The erosion problem? Okay. With the anticipation of El Nino, certainly, we may have, with the warmer, El Nino doesn't necessarily mean heavier rainfalls. It just means more rainfall overall, which could mean heavy rainfall, but that would be more in the summertime, not necessarily as much in the wintertime. So that's less of a concern, I think, overall. Okay. And okay, is all the snow and rain coming in the western U.S. as a result of La Nina, El Nino? It is actually something called atmospheric rivers. They are a well-known phenomena, and these are, the meteorologists have taken a beating recently because of these terms that we use. They're terms we came up with, not for the general public, but for us, but then people started using them. And it is basically what looks like an atmospheric river, where you get a focusing of a lot of moisture brought into the West Coast, but then it's focused on one spot on the West Coast. So it's actually been a benefit for them. We know they happen. Periodically, we get multiples of them. So it's been good somewhat for California, despite the overall rainfall event. So, and then shallow frost, warmer winter soil temperatures, better winter snow soil penetration. Possibly, but I don't, usually there's not very good indications that, that any kind of snow melt in the winter is going to make a big difference in your soils. In the plains, after the soils have warmed up in the spring and you get a big blizzard, that can, winter snowpack, we tend not to think is going to help a great deal in the way of soils. And then what is the metric used to measure drought severity? Okay. There are a lot of, how are we doing on time? Okay. There are a lot of different ways we can measure drought severity based on different indexes. The U.S. Drought Monitor is based on kind of that percentile ranking again, that, you know, like a 1 in, I can't remember what the numbers are off the top of my head. Basically, like a D1 drought should be a 1 in 5 year event or something like that. And all the way up to D4 drought would be like a 1 in 50 year kind of event. So you're kind of putting these on a percentile scale based on the data we have available. And that's all the ranking things that we put into that are based on that kind of percentile scale. So I think that's all the questions, and I'm probably out of time. So thanks for having me. I'll be around for a bit longer, but I have a meeting I have to run out for here quickly in a bit. So if you want to catch me, I'd be happy to chat more. If there's any other questions you have or information you want, feel free to email me. We'll be happy to help you out. So thanks for being here.